In this work, our key contribution is the ease of programming robots using a sensorized gripper to produce quick robot replay results. We built a cable-driven sensorized gripper with off-the-shelf parts and used it to perform a box-in-box assembly task. The gripper is equipped with motion capture markers to measure movement, and a simple bicycle brake handle was used as a lever to actuate the cable-driven gripper. Human demonstrations were recorded of the box-in-box assembly task. A metronome was used to ensure some degree of repeatability across these demonstrations. The time taken for the human to demonstrate each of these trials was a mere 25 seconds. Following the demonstration, the motion capture marker data was used to compute the gripper kinematics with the SE3 filter. The repeated trials of 25 seconds each were collected, and the GMM algorithm was applied to compute the statistical average of the gripper motion. The average gripper motion was used to drive a torque-controlled robot. In real time, to repeat the box-in-box assembly task for about 30 times. Specifically, the robot controller compensated for gravity and issued a damping torque command to avoid oscillations. The gripper motion was executed using impedance control after ensuring that the robot was calibrated and positioned optimally in the task space. The gripper actuation command also was issued to the robot. After each trial of robot attempting the box-in-box task, the box was reset manually. The statistics of robot repetition of this task are displayed. Since the box was manually reset, its initial location is in a sense randomly varied. Depending on the initial location, the robot's success in grasping and assembly also varied. Under these conditions, there were 14 successful robot replays. The robot grasped the box but failed to perform assembly for about 9 times and did not even successfully grasp the box for about 6 times. In the future, we will investigate the possibility of online trajectory adaptation to convert these failures into successes and improve the success rate of our approach. We hope this work contributes towards greater ease of robot programming, and thank you for your time and attention.